In this study, we will look at the secondary succession of the forest in Point Pleasant Park following Hurricane Juan in 2003 by looking at the long-term ecological recovery of the park from 2004 to 2025.
After a devastating Category 2 hurricane wrecked our own Point Pleasant Park, it lost up to 70% of its mature trees. However unfortunate this situation is, it also provides us a unique opportunity. It gave Dalhousie students the ability to conduct a long-term longitudinal study of secondary succession in our own backyard with a mixed woods Acadian forest. Specific geological and topographical characteristics like the park's shallow roots and wide rock faces made this hurricane especially devastating to the old growth, and it turned most of the forest into a blank slate for new species to start anew. Because of the situation we were given, we could explore all manners of forest ecology to devise models to know and predict future trends in our forests. We specifically wanted to test how different species would interact given fresh resources and a new space for succession. These results provided context in how we can think of these forests and could foreseeably be used to aid in regrowth efforts in the future with forests like these ones. Now, we had looked into this park over other forests in the area because it provided us better logistics for our experiment. But it also has a recreational impact on the Haligonian people and deep religious importance to the Mi'kmaq.
Our objectives are to understand how the forest in Point Pleasant Park has recovered since Hurricane Juan in 2003. We look at how the tree community has changed from 2004 to 2025 and use these changes to answer the question of what stage of succession the park is currently in. From this, we can better understand whether the forest is moving towards a more mature and stable ecosystem. Following the damage caused by Hurricane Juan, there were 6 permanent study sites established in the most heavily impacted areas of Point Pleasant Park. Each site measured 20 by 20 meters, and from 2004 to 2025, students surveyed all the living trees that were greater than 2.5 centimeters in diameter. Tree diameter was measured at breast height, which is a standard height of 4.5 feet using a diameter tape. The tree species were also identified. It is important to note that the data was not collected in 2005, 2007, 2016, or 2020 due to various disruptions. From the data we collected, we calculated metrics such as Shannon diversity, dominant species, and species richness. Shannon diversity measures how evenly individuals are distributed among species, dominant species highlights the most abundant species in the community, and species richness counts the total number of different species present. To assess the community changes over time, we use linear regression analyses to examine the relationship between our independent variable, which is always time, and our dependent variables, including Shannon diversity, dominant species, and species richness. We also evaluated R-square values to measure the strength of these relationships and used a significance threshold of p less than 0.05. To answer our first research question of how the overall forest community changed over time, I looked at whether Shannon diversity changed in the forest plots between 2004 and 2025. The null hypothesis states that there is no linear relationship between year and Shannon diversity. In other words, the changes we see would just be due to random variation. The alternative hypothesis states that there's a significant positive linear relationship between year and Shannon diversity, meaning the diversity has increased as time went on. To test this, I used linear regression to examine the relationship between year and Shannon diversity. Looking at a Shannon diversity plot, you can tell that in the first few years after Hurricane Juan, diversity was quite low and variable. This makes sense because the forest had just experienced a major disturbance and was in the early stages of recovery. However, over time we can see a clear upward trend. Shannon diversity gradually increases, especially after the year 2010, suggesting that more species were establishing and the community was becoming more balanced. Our linear regression confirmed this pattern, showing a significant positive relationship between year and Shannon diversity. The R-squared value is 0.33, indicating that about 1/3 of the variation of diversity can be explained by time. This leads us to reject our null hypothesis. Overall, these results suggest that the forest community has been steadily increasing in diversity, which is consistent with the forest progressing through ecological succession as it recovers from the hurricane's disturbance. The increasing Shannon diversity shows that the forest community has been becoming more complex over time. Because Shannon diversity represents both species richness and evenness, the upward trend suggests that more species have been able to establish in the plot areas and that the community is becoming more balanced. The lower diversity in the early years is consistent with the aftermath of the hurricane, which would have removed vegetation, disturbed soils, and temporarily shift the overall forest structure. As the forest recovered, new species began to reestablish, layers of vegetation returned, and diversity increased, which is an expected pattern in secondary succession. As this succession progresses, more ecological niches open up and are filled by species with different strategies, further increasing the community's complexity. Looking ahead, diversity may continue to rise slightly, but eventually will stabilize as the forest approaches its climax community. It is also important to note that the analysis focuses on diversity within monitored plots, and other environmental factors such as ongoing disturbances or park management practices may also influence the long-term community changes. However, overall, the trend of our Shannon diversity plot suggests that Point Pleasant Park is steadily developing into a more mature and resilient ecosystem.
Our research question number 2 was, how has the density of the dominant species in 2004, as well as the dominant species in 2025, changed over time? We decided to attack this problem by using the null hypothesis of there has been no significant change in density of the dominant species, or what is the dominant species over the previous 21 years. In order to be able to first, one, identify if there is a change, right? We're looking for a large significant change, or to see if there has been any change in species to begin with. Be able to quantify a difference in density of our first dominant species, being red spruce, we use a linear regression analysis. We use this to examine both how much the density had changed, but also was it a statistically significant one. Our results showed us that over the 21 years that we were recording for, we saw a positive linear increase of our density, and it certainly was significant. It was not a matter of luck or chance. Much is in the same way for our red spruce analysis, we also analyze the density of our red maple. This is because, as of 2025, with the current data, it is currently the most dense and most populous of our species that we saw in Point Pleasant Park. We also saw a general rise and increase over these 21 years. However, it was more drastic than that of our red spruce. In context, the difference between a red maple and a red spruce. Over the last 21 years, red maple has had an increasing density 6.45 times that of red spruce. This is due to red maple being a much better early successor and having the ability to grow quicker, unlike red spruce, which is a later, slower growing sort of tree. Now, when red maple was given the clean slate sort of environment, it was able to flourish and grow quicker. That doesn't necessarily mean, however, that this will be permanent. Over time, we're likely to see red spruce starting to catch up, maybe less so in density, but also in pure tree volume, as they focus on having wider, thicker trees and having a lot of them, which die more quickly.
Our third research question is, how has species richness in Point Pleasant Park changed from 2004 to 2025 following Hurricane Juan? This was assessed by calculating the species richness for each site through the years and doing a regression analysis. We predict that species richness will significantly increase with time following the hurricane. Figure 9 shows a moderate positive correlation between species richness and time following the hurricane, as indicated by our R-squared value of 0.577 and our regression equation, which shows an average rate of increase of 0.4823% per year. The f-value of 121.4 with numerator degrees of freedom of 1 and denominator degrees of freedom of 89, as well as our p-value of 2.6 times 10 to the minus 18 show significant evidence against our null hypothesis, favoring our alternative, which states that species richness will significantly increase in time following the hurricane. The overall species richness of Point Pleasant Park increases following the hurricane. This is an indicator that ecological succession is occurring as more and more species start to recolonize disturbed areas. During the first years, from 2004 to 2018, we see a sharp increase in species richness, reaching a peak in 2018. This is consistent with the trend in early to mid-succession due to the insignificant increase in resource availability and low levels of density-dependent competition following a disturbance. After 2018, species richness begins to decrease slightly and begins to stabilize around 2022. This may indicate the start of mid to late succession, which is characterized by a reduction in species richness due to competitive exclusion. We expect species richness to continue to stabilize as the forest moves towards its climax community. Based on the results, we believe that Point Pleasant Park is currently in the mid-succession stage. This is indicated by both species richness and Shannon diversity index, as they have reached their peak and begun to decrease and stabilize. This is due to the increased density-dependent competition. We believe that they will continue to stabilize as we reach climax community. However, by examining the density of dominant species, we see that the red maple, considered to be an early to mid-succession species, remains at significantly higher density than the red spruce, which is considered a late successional species. Because of this, we believe that the forest is approaching, but has not yet reached late succession. When dealing with urban parks, such as Point Pleasant Park, it is important to consider the effects of human activity on the park. Urban parks tend to experience heavy trampling, while moderate trampling can be beneficial. Prolonged trampling is harmful. It compacts the soil, reduces its water holding capability and permeability, limits nutrient availability, and disrupts microbial communities, ultimately impairing plant growth. It is important to approach the ecological project using the Mi'kmaq principle of two-eyed seeing, recognizing that both indigenous knowledge and Western knowledge can benefit and improve our approach to the world.
We would like to thank Dr. Allison Schmidt for her experimental design and the previous BIOL2060 students for doing such an excellent job of collecting data regardless of weather or health conditions. We'd also like to acknowledge the data was collected on Amduga, the Mi'kmaq name for Point Pleasant Park, which is the ancestral and unceded territory of Mi'kmaq.
In the early succession stages following the hurricane, a higher density of red maple was found. This pattern is expected as red maple is a pioneer species characterized by rapid growth and strong dispersal abilities, which allow it to quickly dominate disturbed areas. However, red maple is short-lived and shade intolerant. As the canopy closes, more shade-tolerant late successional species such as the red spruce gain a competitive advantage. As a result, we expect the forest to move towards a higher density of red spruce. This shift would result in the forest moving towards its pre-disturbed competition, as the forest consisted primarily of red spruce. However, predicting succession is a gamble, because so much of it depends on chance. Because of this, we will need to continue to monitor the forest to determine if it will return to its pre-hurricane state or whether the disturbance has permanently altered the forest community.
This question asks how much longer it will take for Point Pleasant Park to reach its climax based on the trajectory of our regression analyses. I focus on Shannon diversity and species richness because they capture the main features of a climax community. When you look at Shannon diversity, you can tell that the points begin to lose variation around y equals 2. If you sub y into the linear equation, it predicts that the community will reach a plateau around the year 2028. For species richness, you can tell that the variation is getting lost around y equals 14. When you sub 14 into the linear equation, the model projects a stabilization around the year 2029. Putting both of these metrics together, you can come to the conclusion that Point Pleasant Park will reach its climax community in approximately the next 3 to 5 years.
The research question asked to us today was, does the type of forest Point Pleasant Park is, both ecologically and geologically, play an important role on its succession? And would different forests respond to this hurricane differently? Our answer to that is that Point Pleasant Park doesn't regenerate randomly after Hurricane 1. The type of forest it is plays a big role. For the hurricane, it was considered a late successional red spruce forest, which depended on its high shade and stable canopy conditions. The hurricane opened the canopy by removing trees and exposed our shallow, rocky glacial soils. The environment then shifted to one that favored early successional species. Red maple in particular grows faster, tolerates harsher light, and is better adapted to our aggressive coastal conditions. It quickly became dominant. Other forests wouldn't respond the same way. Areas with deeper soil, more shelter conditions, or entirely different seed banks might generate back into conifers or other hardwood species in the region. The change we see at Point Pleasant Park reflects the specific combination of ecology, geology, and exposure. but it's not a universal pattern.